In this video, we are going to introduce parabola. As you can see in this illustration, a parabola is like a bowl shaped if it opens upward. Later on, we will discuss more about its different orientations. Now let us proceed to the different parts of a parabola. A set of all points in a plane at equal distance to a fixed point is called the focus, and a fixed line called directrix. Always remember that the directrix never intersects the parabola. The line that passed through the focus and is perpendicular to the directrix is called the axis of symmetry. The axis of symmetry intersects the parabola at a point called vertex. The line segment that passed through the focus and is perpendicular to the axis of symmetry is called the latus rectum. The endpoints of a latus rectum is always on the parabola. The distance from the vertex to the focus and directrix is called the focal, denoted as P. Now here are the different orientations of a parabola. If the parabola opens upward, as you can see, here is the vertex HK. And to be able to get the focus, here's the vertex. This is the focus and the directrix. Remember that the directrix never intersects the parabola. And this is the focal distance, denoted as P, the vertex H and K. To be able to get the focus, we have H, K plus P, and for the directrix, we have Y equals K minus P. To get the axis of symmetry, X is equal to H. And if the parabola opens downward, remember that the focus is here and the directrix is here. To be able to get the focus, we will be manipulating still the K. We will subtract P to K, and to find the directrix, we will add P to K. And for the axis of symmetry, if the parabola opens downward, X is still equal to H. And here, if the parabola opens to the left, the directrix is here and the focus is here. So to get the focus, we will now be manipulating the H. We will subtract P to H, and to find the directrix, we will add K to P. And the axis of symmetry, it will be y equals K. For the parabola opening to the right, just imagine that the directrix is here and the focus is here. To be able to get the focus, we will still be manipulating the H. We will add P to H. To find the directrix, we will subtract P to H. And for the axis of symmetry, it is still y equals K.
So let's have an example. We have 2x squared minus 12x minus 10y is equal to 22. So for us to determine the parts of the parabola, we need to convert this equation into standard form. The first thing that we have to do is to group the terms with the x variable on the left side, since x is squared, and the remaining terms on the right side. Next is, we have to factor out the terms on the left side. So that'll be 2 times the quantity of x squared minus 6x is equal to 10y plus 22. For us to get the last term of x squared minus 6x, we will use the formula, the quantity of b over 2 squared. So that's negative 6 over 2 is equal to negative 3, and the negative 3 squared is equal to 9. To maintain equality, we will also add 9 times 2 to the right side. So that's 2 times the quantity of x squared minus 6x plus 9 is equal to 10y plus 22 plus 18. Next is, to eliminate the coefficient 2, we will divide both sides by 2. So that's the quantity of x minus 3 squared is equal to 5y plus 20. To get the standard form of equation, we'll factor out the terms on the right side. So that's the quantity of x minus 3 squared is equal to 5 times the quantity of y plus 4. Next is we determine its vertex. So that's 3 and -4. Next is focus. The formula for focus is h k plus p. So for us to get p, we divide the latus rectum or 5 by 4. So that's 5 over 4. So the focus is 3, -4 plus 5 over 4. So it's 3, -11 over 4. Next is the directrix. The formula for the directrix is k minus p. So that's -4 minus 5 over 4, which is equal to -21 over 4. The axis of symmetry is equal to h, so that's 3. Its orientation is upward, since the squared variable is x and the latus rectum is positive. Our latus rectum is 5. Next is the endpoints. For us to get the endpoints, we first divide the latus rectum by 2 and add and subtract h from it, since its orientation is upward. Then k plus p, or -11 over 4. So our first endpoint is 5 over 2 minus 3, -11 over 4, which is -1/2, -11 over 4. And the second endpoint is 5 over 2 plus 3, -11 over 4, which is 11 over 2, -11 over 4. So let's now go to the graph. We have here the vertex, 3, -4, the focus, 3, -11 over 4, directrix, -21 over 4, axis of symmetry, 3, and the endpoints, -11 over 2, -11 over 4, and -1/2, -11 over 4.
Example is this problem. Parabola with vertex at the origin. Focus on the negative y-axis 6 units away from the directrix. So, the given are the vertex and the focal distance, or the p. Since the vertex is at the origin, the x and y intercept is both 0. So the vertex is 0 and 0, and the p, or the focal distance, is equal to 6 because it is 6 units away from the directrix. To solve this parabola, we need to find the following: the focus, the directrix, the lactus rectum, the midpoint 1 and midpoint 2, and then the graph. And last but not the least, we need to find the standard equation. So first, we will graph what is given. So first, we have the vertex at the origin, 0 and 0, the x and y. The x is 0, y is 0, so it is center. So we know that the focal distance from the focus to the directrix is 6, right? So in order to find the distance from the vertex from each point, we must divide 6 by 2 to get the distance from the vertex to each of the points. Write the standard form of the equation. X minus h squared is equal to 4p times y minus k squared. And the vertex formula is v is h and the k. Next is finding the lactus rectum. So the constant there is 4p. And rp is 6. So now we will multiply 4 by 6. And now the lactus rectum is equal to 24. Next is finding the midpoint 1 and midpoint 2. So the lactus rectum divided by 2 is equal to positive or negative m. Positive or negative m. So our lactus rectum is 24, so we need to divide it by 2. So our M1 and M2 is equivalent to positive or negative 12. So it's time to graph. So we need to count 12 to the right. So we need to move 12 points to the right and 3 points to the bottom. And do the same thing in the other one. We must move 12 points to the left and move 3 points downward and connect. So we now know the focus, the directrix, the lactus rectum, the midpoint 1 and midpoint 2, and we also graphed the parabola. So the next one is the standard form. So earlier, we already know the standard equation of the parabola. So we need to substitute x minus 0 to the power of 12 is equals to 4p times y minus 0 to the power of 12. So x minus 0 is x squared is equals to 4p times y squared. That's all. Thank you.